Okay, I got a request to look at day 5 from the packet, so let me try and give you some information and see if I can help you. Let's start with this first question. It says, Antonio and Juan are in a 4-mile bike race. The graph below shows the distance of each racer in miles, so here's distance, and as a function of time in minutes. We have to understand that we're comparing distance and minutes. We have to keep that in the forefront of our mind. So what I'm going to do is I'm going to outline our two writers here. This one here that I'm outlining in red, okay, that's going to be Juan, okay? And then I'm going to outline Antonio here. There's Antonio, he's in purple, so we can kind of see it a little bit better, kind of sticks out a little bit more. So it says, who wins the race? So we've got to kind of take a look at what's going on. So the race is only 4 miles. So if we go to our distance, right, and so we see here 4 miles, and we follow that, and we can see that these are the 2 points in which they are finished at 4 miles, when Juan reaches 4 miles and when Antonio reaches 4 miles. If we follow that down, all the way down here to our time, we can see the times for each one of them, how they finished at 4 miles. So here, because each block is worth 1, 9, 10, 11, 12, this here for Juan would be 13 minutes, and Antonio would be done in 15 minutes. So who wins the race? Hopefully you can see it's Juan. How do you know? What I just explained, write out how you knew that. Okay? Now it says, imagine you were watching the race and had to announce it over the radio. So you're going to write a little story describing the race. So you have this piece of paper, which is just a lined piece of paper, and you're going to use it to write a story. So let's talk about what's going on so that we can understand a little bit more, because we're talking about distance and minutes. So if things are going this direction, right? So time is passing, right? Time is going up, and as it's climbing, the distance is also going up, right? And so I see that we have that, and sometimes it's gradually. So we can talk about maybe how fast they're going based on this as well. When we see something flatlining like this, when it's going flat a little bit, the distance is staying the same, right? Here the distance is staying the same. But time is passing, so time is still going by. So could we say that maybe they're not moving? It's possible they're not going anywhere. They're just sitting there. If it's a bike race, maybe he had to change his tire or something. You know, we can make a story for that. And then we don't have anything going down, so that's good. So we have going up. We have a little flat line, and sometimes they go up faster than others. So if it's the steeper something is, so as it's going up, if it's really steep, we might think that they're moving faster, right? They might be moving a little bit faster because it's steeper, and as it's flatter, they're moving slower, okay? Because flat distance is the same. They're not moving at all. So if we use this, we're going to write a story, and we're going to tell a story about the race, like we're announcing the race. So if I was talking about Antonio, I would have said, Antonio got off to a very good start, so that when he was about at 5 minutes, he was already 2 miles along, but he ran into a problem and his tire went flat. So it took him almost from 5 minutes, it took him almost 4 minutes to change his tire. But once he got his tire changed, he started to go a little bit more and started to speed up so that he was able to finish the race in 15 minutes. You can tell a similar story about Juan, how he started out slow and then started to, as soon as he passed Antonio. And where does he pass Antonio? He passes Antonio here at the 7-minute mark, right? So Juan is biking around very slowly, and guess what? At 7 minutes, he sees Antonio on the side of the road for whatever reason, and he passes him up. It's kind of like the story of the tortoise and the hare, isn't it? It's kind of interesting. So use these words, write yourself a story. So that's what that part's talking about. So that satisfies the bike race. Okay, then we have this rule of 4. Make sure everybody can see all the parts here. Rule of 4. And so this rule of 4 is based on this graph. And on this graph, you're going to build a table, you're going to build an expression, and from that, you're going to find the slope and the y-intercept. So we have to remember a couple of things, okay? We know that where the line crosses the y-axis, this number here is our y-intercept. So we can automatically, based on this graph, go down here and write that that's what that is. That's a +6, isn't it? Now we need to find the slope. Now we have to remember a few things, okay? So let's remember about slope. slope is rise over run. Okay, so we're in using this idea of rise over run, we're going to go from one point to another point. And it's interesting how this is, you see the scale. The scale is every 2, right? So if I'm going to go from this point to this point, remember it's rise, right? So I'm going to go up. Well, this is going from 2 to 6. So this measures 4, doesn't it? And then I'm going to go over. So I'm going to rise and I'm going to run. And I'm going to run. It's 1 box. But remember, that box is worth 2. So I'm going to take these numbers and I'm going to create my slope. Well, I'm going to say 4 over 2. But what does 4 over 2 equal? Good. So it's 2. So we know that it's positive. It's going uphill, that our slope is 2. So now we have to remember a couple of things. Remember our equation, y equals mx plus b. And we know that m is the slope, right? And the y-intercept that we were just talking a little while ago, that's the b, that's the y-intercept. So we're going to take this information and we're going to write our equation. So we write that equation, y equals, and here is that information. Here we have 2x and then that plus 6. So now we've kind of got some of this going on. You can describe it using words. Describe what's going on with this line. I've talked about it. Write some words here about what is its line. It's crossing at positive 6. It's got a slope that's going up 2 and over 1. Talk about it in words and write that out. Now, the last thing you have to do is build a table. So remember about building a table, right? We have x and we have y, okay? And we already have some points, right? I have a point here, which happens to be 0, 6, okay? I have another point right here, which happens to be -2, +2. And there's a point right here. They give you one right there, right? So this one happens to be -3, and it's not going up and down. It's 0. So I've created a table for those points. I've got 1, 2, 3 points, and that's really all I need to show. So hopefully that explains that. And you can add a couple more points here. I would challenge you to add a couple more points. Find me a couple more points. Go up and over. Find me some more points on this line. Add a couple more and use your words. Okay? All right. Let's take a look at, while we're talking about functions, I'm going to take a look at this page here, which is talking about comparing properties of 2 functions. Okay, and I think you guys can see that. I'm going to try and get it on there. I think is it there? Okay, there. So it says, compare the 2 linear functions listed below, determine which has a negative slope. So in other words, we want something that's going the opposite direction, like one's going up, one's going down. Something is going on here that's causing it to have this negative slope. So let's read the story. So the first function is about chocolate. Okay, function 1's about chocolate. And it says, Jacob has 50 chocolates. He gives 4 chocolates per week to his friend. Let y be the chocolate remaining as a function. So if I look at this table, because this is about function 1, he starts with 50, because that's what it says. He starts with 50. And then he's going to give 4 chocolates a week. So after week 1, so this is going up by 1, right? Each week it's going up by 1. Okay, but what's happening here? Here it's going down by 4. Down by 4, right? And we know that when we're looking for slope, right, we have to remember about slope. Our slope is always going to be rise over run. What's going on? So we have to figure that part out, right? So far it's looking like this one has the negative slope. So let's take a look at function 2. Oops, sorry, didn't mean to hit that. Function 2, which is the cold drinks, okay? And what it's talking about in cold drinks is it's saying Ava has 10 cold drinks at the start of the day. She purchases 2 cold drinks per day for the shopkeeper. Write the rule for the total of cold drinks as a function of number of days. So they're giving us, here's our equation, right? C equals 10 plus 2D. Well, we know that this rise over run, this slope, this rate of change, right? Rate of change. All of these things are always next to the x, right? So that means that this one has a slope of 2. So which one of these has this? I think you guys can tell which one has a negative slope. I don't have to finish that one for you. Okay, Let's go down to number 2. Compare the following functions to determine which has a greater rate of change. So we are looking for the largest slope. Okay? Now, you have two functions here, y equals 2x plus 6 and y equals 6x plus 10. And we talked about this before, that y equals mx plus b. So if we're talking about the largest rate of change, we're just looking at this number and we're deciding which one of these is larger. And I think, again, this is one of those things that you can look at and you can see which one is larger. And the last one here, it says compare the two linear functions listed below and determine which has a negative slope. So once again, we're looking for that negative slope. We're looking for as one thing goes up, one thing goes down. Okay, so it says function 1, it's about toys. William is a toy shop keeper. He has 30 toys at the start of the day. He sold 6 toys per day. Write the rule for the total number of toys. So here he has a function c equals 30 minus 6d. Our function 2, which is about balloons. Daniel has 20 balloons at the start of the day. He blows up 5 balloons per day. So he's adding balloons. Can we say that he's adding balloons here? Daniel's adding balloons. And here William is selling balloons. So one of these is going down. One of these is going to have a negative slope. And I'm pretty sure you guys can see it. If you can't see it by the number that's with the variable, you can tell it by what's adding and what's selling. Okay? Okay, here we go with the last problem from day 5. We have some exponents here. And we have to remember our rules of exponents. Remember, when everything's multiplying, we're going to be adding those exponents. So we're going to be putting things that go together. We see these z's. The z's are going to go together. The d's are going to go together. And then the numbers are going to go together. Okay, so what we're going to do is we're going to take that in our strategy that we're going to use to simplify is we're going to do the numbers. Then we're going to do the z's, then we're going to do the d's. So that's going to be our strategy. We're going to do one thing at a time. So if I work on these numbers one at a time, we know that 7 times 5 is 35. So that part's done and we're good there. So now let me get the z's together, right? And if I show a model of this, here it says that I have 2 z's, right? And then here I have 4 more z's. 1, 2, 3, 4. So altogether, I can see that I have 6 z's. So I'm going to put a 6 right there. Okay, and we'll do the same thing for the d's. Here I have 3 d's. And here I have 8 more d's. 1, 2, 3, 4, 5, 6, 7, 8. And altogether, I have 11 d's. So I'm going to write d to the 11th here. And if we're to think about how do I model 7 and 5 or 5 and 7, it's basically saying that I have 5 7s. So when I have 5 times 7, that's basically saying I need 5 7s. So I have 7 plus 7 plus 7 plus 7 plus 7, and we know that that equals 35, right? Okay, so that's our modeling. So we've modeled, we've tried a strategy here. How do you know your answer is correct? Well, you know your answer is correct by adding and by multiplying. That's how we know. We know that with our variables, we're just going to add those exponents, and with our numbers, we're going to multiply them. So down here where it says write another problem and solve, try it. Create another problem on your own right here. Make one up. It doesn't matter how big it is. I'll make one up right now. Let's say 2x squared y to the 4th 3y squared 5x. That's mine. So now, how do I know my answer is correct? Let me go over here and let me put my answer. Remember, we're going to follow the same thing. Numbers with numbers. I'm going to put the x's together. So here's an x and here's an x. And then I'm going to put the y's together. Here's the y and here's the y. So I'm going to do the numbers. Oh, and I got a 5 here too. So I have a 2 times a 3 times a 5. So 2 times 3 is 6. 6 times 5 is 30. So there's my numbers. So now I'm going to do my x's, right? I have 2 x's here, and that x, that's to the first. So I've had 2 plus 1, that gives me 3. And then the last part is the y's, right? And I have 4 y's here and 2 more y's there, so that's y to the 6. So that's how you finish that last piece.